Hello again, students. This video is about acidic and basic solutions, part 2. Hello, I am Mr. Lemon, and I'll be with you today to explain all what you need to know about acids. But first, let's have a look at the objectives. At the end of this video, you are going to be able to list the names of some acids. List some physical properties of acids. Identify the ions formed when acids are dissolved in water. Write the general formula of acids and describe some chemical properties of acids. Now, prepare the things that you are going to use by opening your booklet on worksheet 23 and your book on page 125. Okay, here I am again. Let's start with the physical properties of acids. Where do we find acids? I'm a poor lemon that you squeeze in order to drink its fresh juice and enjoy the sour taste. I contain acid. My friends pineapple and kiwi also contain acids. All of us have sour tastes, so acids give the food a sour taste. The first property of acids is that it has a sour taste. Let's go and check now some more examples and details about acids. Here are some examples of acids with their uses. Acetic acid found in vinegar. Acetyl salicylic acid found in aspirin. Carbonic acid found in soft drinks. Hydrochloric acid found in your stomach juice, which helps break down food. And sulfuric acid in car batteries. Do you know that some acids dissolve your tooth enamel to form cavities? Okay, no need for your greetings, but I'm back. I'll help you figure out now what is the general formula of acids, but let's check first what do we mean by general formula. This picture shows the sun with different planets. Planets is the general name. Earth is a specific planet. Acid is general. Hydrochloric acid is a specific acid. So, planets is the general name that can be applied on any planet. And similarly, acid is the general name that can be applied on any acid. General formula of acids is the formula that can be applied on any acid. Let's figure it out. Here is the name of some acids with their formulas. Of course, what we are going to look over is the second column, since we're figuring out the general formula. Now, have a look over the different formulas. Can you find something common? Look again carefully. Yes, it's the hydrogen at the beginning of each formula, regardless what's following it. So the general formula of acids is HX, where H, which represents hydrogen, is a must and is found in all formulas of acid, while X, which represents the rest of the formula, varies from one formula to another. Move to your booklet now, open on worksheet 23 and solve part A. Straight away now for the last physical property of acids. We're going to watch a video about it.
Beside these, we will need beakers, 2 carbon rods, bulb, battery eliminator, wires and filter paper. First, connect the carbon rods to the 2 terminals of a battery eliminator through a bulb and switch it on. Now dip the 2 carbon rods in a beaker containing hydrochloric acid and observe. The bulb glows, showing that the circuit is complete. This means that the hydrochloric acid conducts electricity.
So acidic solutions conduct electricity. In other words, they are said to be ionic compounds or electrolytes. Knowing that acids must be found in their aqueous form to conduct electricity, which means dissolved in water. When acids are dissolved in water, they break down to give hydrogen ions of symbol H+, always, and a negative ion represented by X-. For example, in this case, hydrochloric acid dissociated in water to give hydrogen ion of symbol H+, and chloride ion of symbol Cl-. The movement of these ions conducts electricity. Let's do now a small application. Now take 5 minutes to solve this application. Read the directions carefully, then answer. Always put in front of you the general ionization of acids, where acids in water ionize to give a positive ion, which is hydrogen H+, always, and a negative ion X-. Let's check the solution. In part A, hydrogen nitrate, which is an acid, is surely going to release hydrogen ion of symbol H+. And nitrate ion of symbol NO3-, which we have memorized, represents X-. Similarly, in part B, hydrogen carbonate is going to release H+, and carbonate ion, which is X-. Finally, hydrogen bromide releases hydrogen ion and bromide ion of symbol Br-. As it is recognized that all acids release hydrogen ion of symbol H+, and a negative ion X-, which varies from one acid to another. Back to worksheet 23, solve part B. Let's sum up now the physical properties of acids. First of all, acids have a sour taste. Second, the general formula of all acids is HX. Finally, acids are electrolytes in aqueous form, which means they dissociate in water to give their constituting ions and conduct electricity. In the last part of this video, we're going to check the chemical properties of acids. Remember, the term chemical properties means chemical reactions. So, it indicates that we are going to see with what chemical substances does acid reacts.
We need zinc granules, which are metals, dilute hydrochloric acid, and dilute sulfuric acid, and a matchbox. We will put zinc granules in both the beakers. You will observe that zinc reacts with acids and releases a gas. What is the gas which is formed? Take the beaker containing dilute hydrochloric acid, light a matchstick and introduce it into the gas near the mouth of the beaker. You see that the matchstick burns with a pop sound when brought near the open end of beakers. Let's try it again. Take the beaker containing dilute sulfuric acid instead. Again, test the gas formed using a lit matchstick. Listen carefully for the sound. The pop sound is a clear indication that the gas involved is hydrogen. So when a metal reacts with an acid, hydrogen gas is released. You can take hydrochloric acid, calcium carbonate, beaker, and a matchbox. Take some calcium carbonate in the beaker. Add hydrochloric acid to it. A gas is formed and released. Light the match and bring it close to the mouth of the beaker, and it extinguishes. This gas is carbon dioxide. A metal carbonate reacts with acid. Carbon dioxide gas is released and a salt is formed.
Here's my last station over here. Now, as a conclusion for chemical properties of acids, open your book on page 131. Read the conclusion and underline it. Hope you have enjoyed the lesson with me, Mr. Lemon. See you.